Now let us begin with the study of prisms. A prism is, right now we are discussing triangular prisms only. So a triangular prism is a transparent refracting medium which is bounded by two triangular faces and three rectangular surfaces. Herein you can see, this is a three-dimensional image of a prism. Here you can see this face and this face, they are opposite faces and they are triangular in shape. And if you look at this face, this is one rectangular face, this one is another rectangular face, and this one is another rectangular face. So you have two triangular faces and three rectangular faces. The three rectangular surfaces, they are also known as refracting surfaces, and they are inclined to each other. Herein you can see this and this, they are inclined to each other, this and this, they are inclined to each other, and this and this, they are inclined to each other. Okay? And the entire material is made of a single medium. It may be glass or it may be any kind of special transparent medium. So this is how a triangular prisms look like. Okay, and the angle between two refracting surfaces is known as prism angle. Now more terminology is associated with prism is that it has got a refracting edge. Refracting edge is a line which is the line of intersection between the two refracting surfaces. Let's say ray of light is entering from this phase and leaving from this phase, then these two become the refracting surfaces, and the line of intersection of these two refracting surfaces will be known as refracting edge. Okay, now the other refracting surface which is not taking part in refraction is known as base of the prism, and this angle between the two refracting surfaces is known as angle of the prism. Okay, now one more important term used is principal section. It is that plane which is passing through the prism and is normal to the refracting edge. That means, let us say we take a surface like this. So this surface which passes through the any section, let's say this is one section, so this section is perpendicular to the refracting edge. This is known as principal section. Now what happens when a ray of light enters one of the refracting surfaces? It gets deviated, and the deviation of light by a prism is what we are going to study. Okay, let's say this is the ray which is incident. It gets incident at this point on this surface. Okay, this is one of the refracting surfaces. So when it enters, when it strikes here, it gets deviated. Okay, and it will be deviated in this direction. It will bend towards the normal. The normal to this face will be in this direction. So it is bending towards the normal. Now inside the glass prism, it is traveling in this direction, and again it gets incident on this second face, second refracting surface, where the normal is here. Now it will bend away from the normal. Okay, so instead of going like this, it will go like this. Okay, now this angle between the original incident ray, if extended or reproduced in the forward direction, and the final emergent ray which is reproduced in the backward direction, they would meet somewhere here, and this angle will be known as angle of deviation. Okay, we will try to understand all these points in the coming slide. Now the refraction of light through a prism, it follows laws of refraction. Okay, but the laws of refraction has to be applied twice because two refractions are involved. Okay, now in a prism, refraction takes place on the rectangular refracting surfaces. First, when the ray of light is entering the prism from a rarer to denser medium, that is air to glass, and second, when the ray of light leaves from a denser to rarer medium, that is glass to air. Okay, so here when it is entering and here when it is leaving, so there are two refractions. Now here is the two-dimensional figure of, or you can say the ray diagram of deviation of a ray of light when it passes through a prism, triangular prism. Let us say this ray of light which enters gets incident on this face. This angle is known as angle of incidence. This is normal here. Okay, now after refracting it will bend towards the normal. This becomes one of the refracting angles. When it strikes the other face, this becomes the incident angle, but we call it as R2 only. And upon leaving this surface, it is bending away from normal. So this is known as angle of emergence. So angle of incidence, refracting angles, and angle of emergence. Now if you retrace, this is the original direction of incident light and this is the direction of the angle of the emergent ray. So if you find out this angle between these two rays, this is known as angle of deviation, and mathematically it can be proved that R1 plus R2 is equal to angle of the prism. Okay, this angle of prism is sum total of these two angles. Okay, this can be proved. We are not discussing it now because it is not in the scope of the syllabus for grade 10 physics. One more thing is that angle of prism if added with angle of deviation will be equal to I1 plus I2. That means I1 is angle of incidence and I2 is angle of emergence. Okay. Now let us look at various factors which affect the angle of deviation. First is angle of incidence. Now here you can see if you keep on increasing angle of incidence from I equal to 0, then what happens? You can see the angle of deviation is falling, it is reducing, it is decreasing till a certain stage. At this stage you have minimum angle of deviation, and if you further increase the angle of incidence beyond this point, okay, this is the, let's say, one particular angle of incidence at which you have minimum angle of deviation. Now if you keep on increasing angle of incidence, angle of deviation again starts increasing. This is something which has been observed experimentally. Okay, so I'll just brush up. Initially, as the angle of incidence increases, angle of deviation keeps on decreasing till for a certain angle of incidence it attains minimum value of angle of deviation, which we call it as dou minimum. Dou is the symbol for angle of deviation. Okay, now when the angle of incidence is increased further beyond this point, the angle of deviation now again starts increasing. Now for this particular angle of minimum deviation, there is a special case that you should keep in mind, and it is that if the prism is equilateral, then in the position of minimum deviation, this angle of incidence will be equal to this angle of emergence. This angle and this angle will be same, provided all the three angles are 60 degree. Okay, it should be equilateral prism, and this ray which is inside the prism is parallel to the base. Okay, so the refracted ray inside the prism is parallel to the base. Angle of incidence is equal to the angle of emergence. and also the two angles R1 and R2, these two angles will also be the same. Now the second factor is the material of the prism. The refractive index of the prism depends on its material. This we already know. So if the refractive index of the prism is greater, it will produce greater deviation for a given value of angle of incidence. Okay, let's say you keep your angle of incidence at one of the phases as some constant, you do not change. Okay, it remains constant, and then you start experimenting with different types of materials. It will be observed that if the refractive index of the prism is more, we will have more angle of deviation. Okay, these all factors, they have been found out experimentally. Third is color or wavelength of light. Okay, if you keep all other factors, that is angle of prism, angle of incidence, mu, everything, if you keep same, but the ray of light which is entering is varied in terms of its wavelength, then what is seen? Greater is the refractive index, greater will be the angle of deviation. Okay, so it has been experimentally found that the angle of deviation in the case of violet color is more than the angle of deviation for the red color. Now let us look at this light. When this ray of light is entering, let's say it contains many wavelengths, or you can call it as white light, which is polychromatic, or a light which contains multiple wavelengths. So when this ray of light enters the glass prism, what happens? Each constituent ray having different wavelength gets deviated by different amount, different magnitude, and it is observed that angle of deviation for red is least and angle of deviation for violet is the most. Okay, this is also known as dispersion, which we'll be discussing in the coming sessions. Okay, so now you can easily state that the wavelength of light is one of the factor, or the color of light is one of the factor which determines the angle of deviation. Now the last point is the angle of the prism. So greater is the angle of the prism, greater will be the angle of deviation. Okay, with this I thank all of you for today's session.